This is one question. It is from physical quantities and base units. The question is that which quantity could have units of Newton meter per volt? Let's do the calculation for this. When we say Newton meter, so Newton meters per volt. Newton, you know very well, it's coming from force, which is ma, mass is kilogram, and acceleration is meters per second square. So it means when we say Newton, so Newton will be kilogram meters per second square. Meter is as it is. So this can also be written as in this way: Newton meter per volt. Okay. So it means we got the base units of Newton, which is kilogram meter per second square. Meter itself is a meter, it's a base unit. Volts. Let's have a look at volts. Basically, it is energy divided by charge. And we know very well energy is kilogram meter square per second square. Charge, that is amperes second. I can do separately for you this energy kilogram meter square per second square. For example, you say any formula you can take: kinetic energy, potential energy, work done. You will get the same. We take here the work done. So work done, work is equal to force multiplied by distance in the direction of force or displacement. Force is, as we have done it here, kilogram meter per second square. This is force, and distance in the direction of force, that is in meter. So you can see that when you are simplifying this, you are getting it kilogram meter square per second square. Means the same thing what we wrote it here. Charge you are taking from here, I is equal to q divided by t, charge divided by time. From here, charge is equal to I into t. So when you write in the unit, I is amperes and time is seconds. It means charge is amperes second. So you can see over here for the work or energy, we got the base unit kilogram meter square per second square. While for charge, we got amperes second. What did we do? We brought at the place of energy kilogram meter square per second square and ampere second at the place of charge. If you simplify them, you can write it in this way as well: kilogram meter square per second square, amperes minus 1, s minus 1. What does it mean? You brought from the denominator to numerator. Now this is for volts, means base units for volts over here. This complete set you can see over here, this is for volts. Now what will we do for Newton? Already we got kilogram meter square per second square. I think we have to write it here, kilogram. Mass for kilogram is meter per second square. So for the Newton, already we wrote it kilogram meters per second square. I'm writing it as it is. See, I'm replacing. Look, this is Newton meter per volt. Newton meter per volt. I'm substituting the base units over here. At the place of Newton, I'm writing kilogram meters per second square. At the place of meter, I'm writing meter as it is. And at the place of V, what I'm writing, kilogram meter square per second square, and A minus 1 in amperes minus 1 and S minus 1 in per second. Now see, the most important thing is here, meter into meter is meter square, right? Okay, I can write one more step for you people just to make it more easy. Kilogram, this m into m, it is meter square. Bases are same, powers will be added up, nothing is there, so plus 1 is here, s minus 2. Okay, and here it is kilogram meter square, s minus 2, and what I'm getting here, a minus 1, s minus 1. Okay, now you can see what's common in the denominator and the numerator. Kilogram, kilogram, meter square, s minus 2, s minus 2. It means this whole thing will be cancelled with this one, right? kilogram meter square per second square, kilogram meter square per second square. So what's left here? Only a minus 1, s minus 1. I can write it here, 1 divided by a minus 1, s minus 1. Or if I take both in the numerator, it will be ampere second. Can you tell me that ampere second is the unit of what? Base unit? Yes, it is for charge. This is charge. You can see here Q, it is ampere second. It means when we simplified this one, we reached ampere seconds here, and ampere second is charge. So it means our correct answer will be charge. This is our correct answer. When he says examiner, she, which quantity could have units of Newton meter per volt? The correct answer is charge. How did we calculate? Just we substituted the base units for Newton and volts. And I explained you the whole thing. How did we calculate the base units for Newton and volt? We substituted them and ultimately we reached our final answer.